Hello class, this is Miss Womack with Piecewise functions. Remember, a piecewise function is a function that is defined on a sequence of intervals or parts. It's broken into pieces. We'll be practicing writing the absolute value function with the Desmos graphing calculator, just to kind of get us acquainted with piecewise. So let's look at a real-world scenario. Ever got a speeding ticket? Especially with Operation Thunder going on? Well, this one says a town council has just approved the following fines for speeding. So for driving over the speed limit by at least 1 mile per hour but less than 10, you're going to pay $75. At least 10 miles per hour but less than 25, well, you're going to pay $130. And then there's some conditions. We'll get into those in just a minute. And also look at that last one. If you're going at least 25 miles per hour over the speed limit, ooh, you're really paying. That's $375. And that can be expressed as y equals 375. So those are pretty easy to fill out on the table. If I'm going 1 mile per hour over the speed limit, I know I'm going to pay $75. If I'm going 5 miles per hour over, I'm going to pay $75. 8 miles per hour, $75. Things are going to change at 10. Again, we're going to talk about that in just a moment. But if I'm going 25 miles over the speed limit, I'm paying that big old honking fine of $375. Same can be said for 28, 32, and et cetera, et cetera. So let's focus on that one in the middle. It says at least 10 miles per hour, but less than 25 miles per hour. And it's written like this. That's what that means. It's actually two functions combined. It started out life like this. At least 10 means that x is greater than or equal to 10. And the second one said, but less than 25. And this one says x is less than 25. And when you combine them together, they end up looking like that one statement. And sometimes in class, you'll hear me refer it to as x is between 10 and 25. That's very loose because technically we're not including 25. But we literally do see the x is between 10 and 25. So let's now look at filling out this table. It's pretty easy when you start thinking about it. You're going 10 miles over the speed limit, right? Well, according to this right there, you're going to pay what? $130. And then you start reading it. It says, with a fine increasing $10 for each additional mile per hour. So if I'm 11 miles over the speed limit, that is, if I was driving 66 in a 55, I'm going to pay $140. So I can get to the 12 fairly easily. And I see, oh, that's like 20 more bucks. But then we could just keep on right on down the line until we got to 20. But what I'd like for us to do is develop an equation. We know the constant is $130. That's where what begins on this interval. We know we're going to pay $130. But where does it cap out at? That's the question. And so what we're going to do is we know we have this whole idea that $10 is that change that's happening. And so you're tempted to write just simply 10x. But because we're not starting with 0, we in fact have to write x minus 10. Now we're going to distribute the 10 times x, and that's going to give us 10x. And 10 times negative 10 is going to be minus 100. When we combine our like terms and put it in descending order, it's going to be 10x plus 30 is our equation. So we want to determine where does it stop. Well, it stops at 25. So we're going to go ahead and actually solve the 25, and we can solve the 20 for our table as well. So we substitute 20 in for x, and we see 10 times 20 plus 30. 10 times 20 is 200. Plus 30, that's $230. So we now have that for the table. Now, let's go back to our equation. And again, we want to see, where does it end? Where does this all end? This fine. Well, it's right before 25, so we're going to go ahead and actually solve for 25. That's going to be 250 plus 30. That's going to be 280. You'll see why we did that in just a moment. Even though you won't pay the 280, you're going to need that for your graphing. So here's our summary. Again, for the domain, at least 1 but less than 10, it is y equals 75. For the domain of at least 10 but less than 25, we simplified that equation to 10x plus 30. For at least 25 but less than, and I put 100 here, then y equals 375, and it can be written like this. But and you notice that on this last part that I've written this way, I would have accepted it that way. I would have accepted it as x is greater than 25. Either one of those would have done. But this is kind of keeping with the reality of the fact that a car, how fast does a car drive? But on our graph over here, it's going to be this way. So let's just say x is greater than or equal to 25. Just for the purposes of graphing, but it should cap off somewhere and stop. It's a car. We can't go light speed on the road. So I have all of them graphed over here, and you can approximate where to find the 75. And notice right here that I've actually closed the circle. And again, I tried my best to find 1 mile per hour, and I closed the circle. I opened the circle at where 10 is at. Now I'm going to go up to 130, and I'm going to put a closed dot at 10, because I know I have to pay, if I'm caught speeding 10 miles over the speed limit, I got to pay what? This amount right here. And if you're having difficulty on the graph paper, just make the dot bigger. Nobody will know. All right. And we just found out where that cap was on the previous page. Do you remember? Let's look again. It was 280. So I'm going to go approximately to $280, which is right about in here. I'm lining it up with the 25, which is just past 24. I'm going to open that circle. It's about right there. Yes. And oops, that's a pretty rough looking line. So that's how we're going to graph our piecewise functions, and this is how they're represented. Again, you can recognize them because they're in pieces on a graph, and then also over here you can see it's written with this large bracket and all 3 functions. So is this a function in fact? Yes, because if we place a vertical line right here, we do in fact see that at no point, if you drug that line across there, would 2 points be hit. So we can see that this is in fact a function.